Okay, in this video I'm going to attempt to do all of the exercises on page 346 in chapter 8. So the first section there, exercise 5, says to find the sum of each sequence, and C is checking to see whether or not you can read summation notation. So the first one is a bit of a, well, it's a bit of a trick. The formula is a constant, so it's the first through fifth term in the sequence is all 4. So what we have there is a sequence that looks like this. And if we add them all up, because it is a summation, we get 5 4s, and the answer is 20. That's easy. Let's try to do another one like this one over here. Here it's from k equals 0 to 3, k cubed minus 1. So that one is 0, 1, 2, and 3. But those are plugged into this formula here. Sorry, this isn't accurate. It's K0, K1, K2, and K3. And if we figure out what these values are for K0 through 3, it's K cubed minus 1. So if I take 0 cubed minus 1, that equals 0 minus 1, or negative 1. So that's my first term. The second term, let me write this out here. This is sum to 3 from K0, K cubed minus 1. So negative 1 is the first term. 1 cubed minus 1. 1 cubed minus 1 is 1 minus 1 is 0. 2 cubed is 8 minus 1 is 7. And 3 cubed is 27 minus 1 is 26. So those would be the values in my sequence. Let's look at number 6 here. Express each sum using summation notation with the index k equals 1. So k equals 1 is what goes underneath here. This is called the index underneath the sigma. So every one of them will have a sigma with k equals 1 under the bottom. That's the easy part. So let's just do A and D. So A shows 1, 3, 5, 7. So that's 4 terms. So this is 6A, where it gives us 1 plus 3 plus 5 plus 7. The sigma notation, k equals 1 to, well, it's 1, 2, 3, 4, the fourth one. K equals 1 to 4. And what is the formula here? It looks like it's 2k minus 1. And how did I get that? I got that off the top of my head, actually. What I'm trying to do is take the position here, 1, 2, 3, and 4, and use the numbers 1, 2, 3, and 4 in some kind of a formula to result in the value shown here. So twice the position, or twice the term's position minus 1, will give us these values that were given. So that's the summation notation for that one. It's a little bit hard to reverse engineer these things and figure out the formula. This one here, I'm not going to write that out, too many values here, but you see a 2 here, a 3 here, and an n here. So, oh well, here's the formula here. 5 to the n over n. Well then, and it goes up to n. So, the summation notation, we know it's k equals 1, it told us that. This is 6D, by the way. So it starts at 1 and goes up to n. Told us that already because it goes up to n. And the formula is 5 to the n over n. And there's the summation notation for D. Let's look at a couple of 7 here. write the first 5 terms of each arithmetic sequence. Now the definition of an arithmetic sequence is that there is the value d, which is the distance between each term. It's always constant. So 7 to 11 is 4, to 15 is 4, the next one has to be 4 higher, which is 19, and then 4 more, which is 23. Too easy. This one is just descending by 3 each time, so the next 2 values are easy. This one gives you A and D. A is the first term, D is the distance. So if the first term is 4, the next term will be 2 higher, and then 2 higher, and then 2 higher. So it would be 6, 8, 10, 12. And here we have one as a fraction. It starts at -2/3, the distance being 1/5. So we'll have to do a little math. Go figure. So this one is 7f. So 7f. Where a equals -2/3 and d equals 1/5. So the first term is -2/3. The next term will be 1/5 higher, so I have to go -2/3 plus 1/5. It's kind of difficult. And that's the same as -10/15 plus 5/15, which equals, I'm sorry, that's 3/15. And so that would be -7/15. And then I'm going to add another 3/15. That's -4/15. And I'm going to add another 3/15, so that's -1/15 is the next one. So in each case I'm adding 1/5, and 1/5 is 3/15, so that's why I get this stuff. So the next one, add another 3/15, so it's 2/15. It's positive now. So they're the first 5 in that sequence. And lastly, let's look at the section 8 here. Find the indicated arithmetic term. This is requiring us to use the formula derived a couple of videos ago for a arithmetic sequence. It's A1 term n is A1 plus n minus 1 times the distance between each term. So this was the formula for an arithmetic sequence. It'll give us whatever the term is. And the first example here is asking us if the first term is 5 and the distance is 3, find the 12th term. Which means T12 equals 5 plus n, well, 12th term, so 12 minus 1 times the distance, which is 3. So we can just figure that out. Equals 5 plus 11 times 3. 11 times 3 is 33. And equals 38. Okay, some of them, they get a little bit more complicated because they introduce decimals or they introduce fractions, but it's the same idea. All you're doing is plugging it all into that formula and making sure that that you do the math correctly. So this is all grade 8 math here, where you're multiplying fractions and decimals and etc. But this is the formula you have to know. That one should be committed to memory.